Good afternoon. Today we are going to look at a few questions from the unit 9, chapters 2 and 3. That is single slit diffraction and interference. Okay. So let's solve this question first. The diagram shows diffraction pattern for light passing through a single slit. We have an intensity graph and the diffraction angle. The moment you see the word diffraction pattern, try to recollect equations of diffraction. Now, here the question is asking for what is the wavelength of light upon width of the slit? When you see this pattern, that is this intensity pattern, it's extremely clear that this is talking about single slit diffraction. So, which is the equation dealing with single slit diffraction? That is theta equal to lambda upon b. Lambda is the wavelength of light, b is the slit width. Yes, let's look at this. This is the wavelength of light on the slit width, which means the question is asking for theta. So, this is the equation for first minima. So, I'm going to consider the first minima here. What is the first minima? 1 times 10 to the power -2 radians, which is 0.01. Therefore, the answer is here. Let's look at this question number 2. It says monochromatic light of wavelength lambda passes through a single slit. Again, it's talking about single slit diffraction then. The slit width is B and produces a diffraction pattern on a screen. Which combination of changes to B and lambda will cause the greatest decrease in width of the central maximum? So, whenever they are talking about central maxima, remember they're talking about 2 theta. All right. Our equation is again theta equal to lambda upon b. Now the question is, it has to get decreased. If theta has to be decreased, which means lambda has to decrease or b has to increase. So let's look for where lambda is decreasing. Lambda is decreasing here and lambda is decreasing here. So it is not B, it is not B. Now, where is B increasing between A and C? B is increasing here. Therefore, the answer is C. Let's look at the next question. Light of frequency 500 terahertz. Now, here there is a catch or a tricky point. That is, usually when we discuss about diffraction, all the questions or all the concepts are talking with respect to wavelength, but here it is with respect to frequency. Is incident on a single slit and forms a diffraction pattern. The first diffraction minima, so this is talking about the first diffraction, occurs at an angle of 2.4 times 10 to the power -3 to the central maximum. The frequency of the light is now changed to 750 terahertz. So now the frequency is changed to 750 terahertz, that is the frequency increase. Sorry, yes, frequency increased. So what will happen to lambda? Lambda decreases. What is the angle between first diffraction minimum and the central maximum? So when you had 500 terahertz, here is the first minimum, and this value is given as 2.4 times 10 to the power negative 3. Now they are changing this to 750 terahertz. So what will happen to this first minimum? Look at the equation. Theta equal to lambda upon b. Frequency is increasing, which means lambda is decreasing, which means theta has to decrease. That's the first thing. So when I look into where is theta decreasing, it cannot be the same. It cannot be increased. It has to be either A or B. So I'm going to look into the equation again. In this, lambda is changing, so automatically theta will change. However, the slit, it is staying the same. So which means B. So I can write theta 1. So I can write B as a constant, which means lambda 1 upon theta 1 is equal to lambda 2 upon theta 2, right? However, we know that lambda and frequency, they are inversely proportional, right? So this equation is equal to, I can just rearrange it, lambda 1 upon lambda 2 will be equal to theta 1 upon theta 2, which will be equal to F2 upon F1, right? Because lambda and frequency, they are inversely proportional. So now my equation changes out to be theta 1 upon theta 2 equal to F2 upon F1. Let's put in the values. Theta 1 is 2.4 times 10 to the power negative 3 upon theta 2, which I don't know, or that's what we need to find out. F2 is 750 terahertz upon F1 is 500 terahertz. So this gets cancelled, this gets cancelled. So what we have is 75 upon 50, which is equal to 3 by 2, right? So theta 2 will be equal to, we are making theta 2 as the subject, so we'll get 2.4 times 10 to the power negative 3 multiplied by 2 upon, so 3 and 2.4, which gives me 0.8 because 8 3s are 24. That's how I am getting. So and 8 2s are 16. So it is 1.6. I hope it's clear for you. Review it once again. The relation between theta 1 upon theta 2 for lambda is lambda 1 upon lambda 2, and it's equal to F2. If you remember this equation, it's not there in the data booklet, but if you remember this equation, you'll be able to solve any questions like this wherever the wavelength is changing. Let's look at number 4. In a Young's double slit experiment, so we are moving from single slit to double slit. Double slit experiment. Distance between the fringes is too small. Whenever you see the word too small, that means they are talking about negligible width, negligible slit width. What change would increase the distance between the fringes. So when you talk about double slit, it's of reasonable slit width, then the distance. So the question is asking, what changes would increase the distance between the fringes? We want fringes that are apart. So our equation for double slit is x equal to lambda capital D small d. And distance between the fringes should increase. So x should increase, which means lambda should increase, d should increase, small d should decrease. Before even looking at the option, this is the first thing you should do. So it becomes easy for you. So increasing the frequency of light. When you increase the frequency of light, what happens? The lambda decreases. So no way, it's not possible. Increasing the distance between the slits, which is d, right? Small d has to decrease. But here it says increasing, therefore no. Increasing the distance from slits to screen, capital D, yes. So C is the answer. This is irrelevant. All right. Moving on to number 5. Look, the graph shows the variation with diffraction angle of intensity of light when monochromatic light is incident on 4 slits. Monochromatic light means light of single wavelength. Okay, so here the question was for 2 slits. Now the question is increasing to 4 slits. Okay, quickly, when the number of slits increases, the secondary maximas will start to appear. These are the secondary maximas. It will start to appear, and the number of secondary maxima will be equal to n minus 2. Since we have 4 slits, there are 2 secondary maxima. You can see secondary maximas, 2. All right, now let's look at the question more. So the number of slits is increased, keeping the width and the separation of the slits unchanged. So 3 possible changes to the pattern. So slit width is not changed. Separation of slits also not changed. However, number of slits is increased. So what are the changes? When the number of slits increases, of course, we know that the pattern becomes sharper, right? So keep in your mind, when the number of slits increases, the pattern becomes sharper. The separation of the primary maxima, so which is this one, this one, this one, this one, and this. Because the slit width is staying the same and the separation of the slits are not changing, the position of the primary maximas will also not change. Okay, just by increasing the number of slits, you cannot change the position of the primary maxima. So possible changes of the pattern, separation of the primary maxima increases. This is a wrong statement. The intensity of the primary maxima increases. Yes, I said it becomes sharper. So intensity increases and the width decreases. These two are correct. Now let's look at the options. So 1 and 2, no. 2 and 3 only. So answer is C. So before even looking at the options, students, I would like you to recall the concepts that you learned, try to answer the questions, and then choose the correct answer. Let's look at the next question. Yes. Monochromatic light is incident on a double slit. Both slits have finite width. The Light then forms an interference pattern on the screen some distance away, which graph shows the variation of intensity with distance from the center of pattern. Now, this graph is for slits of negligible width. So it should be written as negligible width. Here, the question is saying the slits have finite width. So I will remove this from the choice. Now, by looking at this pattern, we have never studied anything similar to it. So I'm just trying to ignore this also, leaving me these two graphs. Now, let's read the question once again. Because it's a finite width slit, light forms an interference pattern on the screen some distance away. Whenever we have finite width, the interference pattern will be modulated by the diffraction pattern. Interference pattern modulated by diffraction pattern. I hope you remember this is something that we learned in class. Okay. So where is that modulation happening? Yes, here also modulation is happening. However, this in between small fringes, they are missing. Therefore, not this. Answer is D. Number 7. Monochromatic light is incident on 4 rectangular parallel slits. The first principal maximum is observed at an angle theta to the direction of the incident light. The number of slits is increased to 8, each having same width and spacing as the first 4. Look, even here, when I was explaining this part to you, I said when the number of slits are increasing but keeping the width and the separation unchanged, the separation of the primary maxima will stay constant. That's what I said. So let's see, I did not even look at the options. Let's see what are the options. 3 statements about the first principal maxima with 8 slits are. The angle at which it is observed is greater than theta. Do you think it will be correct? No, it will stay the same. Intensity increases, width decreases as it's becoming sharper. Therefore, answer will be again 2 and 3. So answer is C. I hope you are able to understand and you're getting hold of kind of questions that you will get for your exams. 8. White light is incident normally. Now we are moving on to diffraction grating. So we started with single slit. We went to multiple slits. Now we are moving on to diffraction grating, which has many number of slits or groups. So you have diffraction grating X and Y, right? I have told you in class, when you have to, or when the question is talking about two different things, always try to make a table so it becomes easy for you. So X and Y. Y has greater number of lines per meter. So I'm going to use capital N to show that greater number of lines than X. So since it has smaller number of lines, I'll put N, small n. 3 statements about differences between X and Y are adjacent slits in the grating are further apart for X than for Y. Think when the number of slits are less, the distance between it's the same. We are talking about 1 meter. 1 meter. Yes. 1 meter. area that is getting illuminated. You're talking about here, you have less number of slits, whereas the Y, you have more number of slits. So where will the distance between the slits more? It will be in X. So adjacent slits in the grating are further apart for X than for Y. So this is a correct statement. Now, angle between a red and blue light in a spectral order is greater in X than in Y. It's difficult to figure out at this point, but let's see, because when I look into the options, I'm going to take a chance actually. The total number of visible orders is greater for X than for Y. Visible orders is greater for X than for Y. When you look into that equation for diffraction grating, n lambda equal to d sine theta, right? So we can say the number of orders, that will be, that is the number of orders is n, that will be inversely proportional to the number of lines in the grating. So because we have less number of lines in X, that is small n, therefore the number of visible orders for X, n will be, this n will be greater, which is telling me that the answer is C. So two things, it's further apart because it has less number of lines, and when the number of lines is less, the number of orders that are visible will be more. Now, question number 9. It says, light wavelength lambda is normally incident on diffraction rate of spacing 3 lambda. So I'm going to write spacing d equal to 3 lambda. What is the angle between two second order maximum? So let's draw the diagram. This is the grating. Light is falling. This will be my 0th order. This will be my first order, both sides, first order. This will be my second order spectrum that I'll be observing. The question is asking angle between two second order maximum. But according to the equation, n lambda equal to d sine theta, this theta is the angle between 0th order and any of the order that you're considering. So this is the angle theta. But the question is asking us to find out the total angle. So if I find out theta, the total angle will be equal to 2 theta. All right. So let's find out. Order is 2. So 2 lambda equal to, the spacing is 3 lambda sine theta. So making sine theta as the subject. So lambda got cancelled. Sine theta equal to 2 upon 3, or theta equal to sine inverse 2 upon 3. We want 2 theta. So 2 theta will be equal to 2 sine inverse 2 upon 3. Therefore, the answer is C. Always draw the diagram to see whether they are asking for theta or 2 theta. So this is always a tricky question. Moving on to number 10. A beam of monochromatic light is incident on a diffraction grating n lines per unit length. Angle between the first orders is theta 1. So what is the actual angle of diffraction? It will be theta 1 upon 2. Right? So what is the wavelength of the light? So let's look at the equation. N lambda equal to d sine theta. N lambda equal to, instead of d, because they have given in terms of number of lines, so we need to rewrite this equation 1 by n sine theta. Right? So now I'm going to use the info given in the question here. It is the first order, which means n equal to 1. So 1 times lambda equal to 1 upon capital N sine, what is theta? Theta is theta 1 upon 2. So equation for lambda is 1 upon n sine theta 1 upon 2, which is d. Because it has to be 1 upon n, don't get mixed up. Okay.